Okay, let's look at section A, question number 1. So ice floats in water. So this is due to, the answer is C, intermolecular forces of hydrogen bond. Alright, so we know that in water we have H2O. Okay, H2O molecules. So this H2O here, we have 2 hydrogen atoms and bonded to 1 oxygen atom. So this is not involving ionic bond. Alright, so this is what we call as covalent bond because it involves sharing of electron. But in ice, we know that there is not only one molecule of H2O. It has lots of H2O molecules. Alright, so when we have lots of H2O molecules, the interaction between the molecules itself, we call it as intermolecular forces. Okay, and one of the intermolecular forces is hydrogen bond. So to look further, we can see here. Alright, so this is the hydrogen bond, okay, between the molecules. Okay, so when liquid, okay, becoming solid state, which is hydrogen bonds becomes more stable. Okay, so this is the arrangement of liquid, okay, of H2O molecules when it's become solid. Alright, so when it becomes solid, it becomes more stable. Okay, arranging the water molecules far apart from each other, and we can see here it consumes lots of spaces. Alright, so this making ice have a lesser density than water, so making it float. So because of the hydrogen bond, it becomes expanding, and then it become more stable, and then it will arrange in a beautiful arrangement, so making it consume so much space, so it becomes lesser density than water, so it will float. Alright, okay, so the answer is C. Okay, and second one, the boiling point of liquid is the temperature at which the vapor pressure is equal to. So the answer is C, atmospheric pressure of the current location. We know that the boiling point of liquid is the temperature at which the vapor pressure, the keyword is the vapor pressure, okay, must equal to, okay, to the atmospheric pressure, okay, to the atmospheric pressure, okay, atmospheric pressure. Alright, so at this point, the liquid changes into a vapor state, and this is when the boiling happened. Alright, this is when the boiling happened. So the answer is C.
Okay, let's move to question number 3. It's stated that if 2.3 gram occupies 0.87 liter at 690 torr and 37 degrees Celsius, calculate the molecular mass. So this question wants you to calculate the molecular mass. So you have to extract the information given. So we have mass M, volume, pressure, and temperature. So what you have to do is you have to match it with the formula, right? So showing you here is the work, okay, given by one of the student. Okay, so the formula here is from PV equal to nRT. So you can make it into MR equal to MPV over RT. Okay, and you substitute the value, but you have to make sure you have to convert temperature from degree Celsius to Kelvin, and also pressure from torr to atm. Okay, why you have to? Because you want to use R. Okay, R constant, the value is 0.08276. Okay, so you look at the unit given, atm, liter per mole per Kelvin. So That's why for the temperature you have to use Kelvin, and for the pressure you have to use ATM, right? So after you put the values, you calculate and you will get 74 gram per mole for the molecular mass. Okay, so the answer for number 3 is B. Next, we move to question number 4. Which of the following processes is used to convert a substance directly from solid to gaseous state? Right, so from solid to gaseous is sublimation. So the answer is C.
Okay, for question 5, we are going to do water displacement method. Look at figure 2.10, apparatus set up to collect gas underwater. We are getting the gas here and we have to deduct the pressure of water here. So, we know that the atmospheric pressure is the barometer reading 736 torr, and then we minus the pressure of water, and now we get the pressure of H2. This is pressure 1, pressure of H2. Okay, we are going to use combined gas law. This is combined gas law. P1 V1 over T1, P2 V2 over T2. We want to find V2. So we insert all the values over here. Right? And then we're going to get 25.9 ml, which is which option? B. B. Okay, that's it.
Okay, for question number 6, let's look at the question. Which of the following statements is false? Okay, the first option is van der Waals equation is correct for real gas. This is what we know. Real gas is gas that is not ideal. So the first statement is indeed correct. Okay. For question B, for option B, molecules of an ideal gas are assumed to have no significant volume. This is also correct because you know that ideal gas has no volume and also no intermolecular forces. Right. For option C, let's read the properties of nitrogen gas will deviate more from ideality at negative 100 degrees Celsius than at 100 degrees Celsius. So here we know that N2 is real gas. So real gas will have ideal behavior at high temperature. Here it says will deviate, meaning farther away from ideal behavior. So the negative 100 degrees Celsius is correct. It is deviating far away from ideal at low temperature than high temperature. So statement C is correct. We only left with statement B. Molecules of methane at high pressures and low temperatures have no attractive forces between each other. The thing that we are looking at here is no attractive force. No attractive force is referring to ideal behavior. So ideal behavior should be at low pressure and high temperature. Therefore, this statement is not right. So the answer is B for number 6. Thank you.
Question 7. Okay, which of the following atoms or ions has the electronic configuration as follows? So given in the question 1s2, 2s2, 2p6, 3s2, 3p6. So we need to count the number of electrons here. 2 plus 2 plus 6 plus 2 plus 6. So it is equal to 18 electrons. So based on this atom, we need to identify the number of proton first. Potassium, as we know, is 19. Yeah, we identify the proton number first because proton numbers is given in the yellow page. Okay, Ne neon is 10, Cl is 17, and Mg is 12. So right now, so look at the answer of A. Is it ion or atom here? Okay, so it is atom. So no positive or negative charge. So 19. So it is not, okay, it's not the same as given in the question 18. So the answer is wrong. So neon and E, neutral, 10. So wrong. So Mg, 12. 2 plus, remove 2 electron, okay, become cation, means that it is remove 2 electron, so it is 10. Right, okay, so 10, so net is not the same as given in question 18. So Cl, 17, proton number, so we have charge here, negative anion, so means that we 17. Okay, so we add, okay, 1 electron here, right, so become 18 electron, right, so the answer is C. Okay, so how many electrons are there, p orbitals, in atom of rubidium? So first we have to know the rubidium proton number based on the yellow page. So given the proton number of rubidium is 37. Okay, 37. So we need to do the SPDF based on, okay, Aufbau principle. So 1s2, 2s2, 2p6, 3s2, 3p6. So this one 18, 4s2, okay, 20. Okay, so 17 more, 4s2, 3d10. Okay, 20, 30. Okay, so 30 for P6. Okay, 36, and then 5s1. Okay, so this is the, okay, SPDF notation for rubidium. Okay, 37 Rb. So you need to calculate the electrons are there in p orbitals. So p, let's take a look at p. We underline the p, 2p, 3p, 4p. Okay, so 6 plus 6 plus 6. So the answer is 18. Okay.
Alright, let's see how to answer question number 9. Okay, calculate the wavelength of a photon that travel from 5th energy level to 2nd energy level. Okay, so from this question, we know that, okay, the N1 is equals to 2. Okay, and N2 is equals to 5. Okay, so you have to use the formula, the Rydberg constant formula for, the Rydberg formula for Rydberg equation for for lambda, calculating lambda. So we have 1 over lambda equals to RH, 1 over N1 square minus 1 over N2 square. Okay, and make sure your N1 must be less than N2. Okay, because lambda is, it must be in positive, okay, positive value, because lambda is distance. Okay, so if you put N2 large, N2 is smaller than N1, you will get negative answer. Okay, so we do the substitution like your friend did here. Okay, after that, okay, make sure to get 1 over lambda. Okay, so it is 4.34 times 10 of negative 7. This is in meter. Okay, and the question give you answers in nanometer. So how to convert to nanometer? We multiply with 10 to the power of 9. Okay, and then you will get the answer for 34 nanometer. So the answer is B. Okay. Let's go to question number 10. Which of the following statements explain the drawn orbital diagram below? Okay, so from this orbital diagram, you can count the number of electrons that consist in this element. Okay, we have 2 plus 2 plus 6 plus 2 plus 6 plus 2. Okay, and then plus 9. So the number of electron is 29. Okay, like written here. Okay, so this atom has 28 electrons. Of course, it is wrong because we have calculated it has 29 electrons. The Pauli exclusion principle is not obeyed. This is not the correct statement here. Okay, it does not explain the orbital diagram above. This atom does not comply with Aufbau principle. Okay, does it comply with Aufbau principle? It does comply with Aufbau principle. Okay, but also not explain about this orbital diagram. This atom is not stable since its 3D orbital is partially filled. Okay, if you refer to your book, the last page of chapter 3, okay, the element that has 29 electrons is actually copper. Okay, copper with 29 electrons. So the answer is actually D. Okay, this statement explains the orbital diagram of copper because copper has it's the anomalous case, okay, for the electronic configuration, which the configuration does not obey the Aufbau principle. If according to Aufbau, the electron must be filled, okay, in the orbital according to the increasing energy level. Okay, so this one is the actual, okay, this is the actual configuration of copper. Okay, but this is the configuration of copper which obey the Aufbau principle, but the actual, okay, Aufbau principle. Okay, but if we want to write the actual configuration of copper 29, so it should be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s1, 3d10. Okay, 4s1, 3d10. Okay, right here 3d10, so it is fully filled, more stable than partially filled. So this one is partially filled. Okay, so we have finished question number 10 from section A.
Okay, let's look at section B, structured question. So question number 1. So when you look at the question, first thing you need to identify, to extract all the information that you have. Okay, we have here number 1, we have the volume, okay, of the container. The volume is given there 2 liter, and then we have also the temperature. So the temperature here it's stated 295.15 Kelvin. And also we have the mass. Okay, we have the mass of H2, okay, and also the helium. So both having 1 gram. Okay, so the first question, it wants us to identify the partial pressure. Okay, the partial pressure for each constituent. Okay, for H2 and He. Alright, so if you notice, okay, we already have these two information, okay, and these two information is related to this mixture. Okay, the only formula that we can use related to this information, okay, so we the easiest formula, alright, so we can use the ideal gas equation. PV is equal to nRT because P is the one that we want to identify, the partial pressure. Okay, V is given in the question, and we can find N mole from the mass given. Okay, and then R is constant, T is also given in the question. So first thing, of course, we need to know the mole of each constituent. So N Okay, you must remember it, okay, by now the formula of mass n is equal to, sorry, the formula of mole n is equal to mass over molar mass. Alright, so for n H2, okay, hydrogen, okay, its mass is 1.0 gram. Okay, molar mass, okay, we know that it has 2 of hydrogen, so 2 times the molar mass is 1. Okay, so gram per mole. Okay, and you will get 0.5 mole of H2. Okay, this is for H2. Mole for helium, okay, same formula. Okay, it also has 1 gram divided with its molar mass. Alright, so 4, you can refer to your yellow page. Okay, 4 gram per mole. Okay, so if you press the calculator, you will get 0.25 mole of helium. Okay, so after that, when you have calculated the mole, okay, so what we need to do is we must substitute in the formula. So let's calculate, okay, the partial pressure of H2 first. Okay, so now nRT divide with its volume. Okay, and you just substitute the value of n for H2 that you have calculated before, 0.5, okay, moles, okay, times with the temperature. Remember, for ideal gas equation, temperature must be in Kelvin. Alright, so it's given in Kelvin, so just substitute the value, 295.15 Kelvin. Alright, and then times with the R value, okay, 0.08206. okay, so it has the unit of LATM, okay, over mole, okay, K. Alright, okay, now divide with the volume. Volume itself is 2 liter, so you just press in your calculator and then cross out all the same unit that you can cross out. Okay, so the final answer, okay, will be 6.055 atm. Okay, for the H2. For the helium, also same step. Alright, just substitute the value. Okay, for n, you need to use the n for helium itself. Okay, 0.25 mole. Okay, times with the temperature in Kelvin, times with the R value. Alright, and the unit, okay, and then divide with the volume. Okay, so you cross out the unit. Okay, the unit is as above. Okay, you can cross out liter, and then mole, K, K with K. Okay, alright, so you will get the final answer is 3.0275 atm. Okay, so that is the partial pressure for H2. So let's look at the distribution of the mark. Alright, so if you calculated, okay, the value of the mole for H2 and He, correct? Okay, so you will get 1 mark. Okay, so both of them must be correct, then you will get 1 mark. Okay, another mark, it goes to the substitution of the first formula, this one, substitution, and the final answer itself together with the correct unit. You must write the unit. Okay, so this is 1 mark, and then another 1 mark for the final answer for hydrogen. Okay, partial pressure for partial pressure for He. Okay, so this He, 1 mark, because this is the same step. Okay, same substitution. So it just we just write the we just so we just give the final answer 1 mark. All right. Okay, so together, all together is 4 marks for the first one 1A. Okay, question. Okay, next one, still in question number 1. So what is the total pressure? So we have calculated the partial pressure for each constituent. So for the P total, okay, the total pressure, we just calculated the total partial pressure for helium and also for the hydrogen. Okay, so using the information that using the one that you have calculated in the previous question, so you just substitute it. All right, so 3.0275 plus partial pressure of hydrogen is 6.055. Okay, so the final answer will be 9.0825 atm. Okay, so you will get 1 mark for the correct answer. Alright, together with the correct unit. Okay, next one. What are the mole fractions? Okay, so mole fractions for H2 and He, you have calculated the mole for each constituent. So we just substitute in the mole fraction formula. For H2, the mole itself is 0.5. Okay, divide with total mole, so 0.5 plus 0.25. okay, the mole for the helium, so we will get 0.6667. so remember, mole fractions, so it doesn't have no unit. Okay, that it doesn't have any unit, so it just numbers. Okay, because it is a fraction. So for the mole fraction for helium, okay, same steps, 0.25 for its mole number, so you divide with the total mole. Okay, 0.5 plus 0.25, so you will get 0.3333. Okay, so for the correct answer, 1 mark for each correct answer. Okay, and then next. Okay, next one, still in question number 1B. What is the density of a methane CH4 gas at STP? So the question gives us the biggest clue. Okay, so at STP. So when the question mentioned about STP, we already have two information. The first one, we already have the temperature. Temperature must be 0 degrees Celsius, which is equal to 273.5 Kelvin. Okay, and then we know that at STP, pressure must be in 1 atm. Okay, and when it's involved gas, okay, and the question asks about density, so we know that from ideal gas equation, PV is equal to nRT, we can actually derive this equation. Okay, so PV is equal to N, and we know that it is mass over molar mass, right? And then RT. Okay, so from here we can actually derive to get the density. So P, alright, and then is equal to mass, okay, times with R times with T. Okay, it divide with volume times with molar mass. Okay, so mass over volume is actually density. So we have here P is equal to density, okay, RT over molar mass. Okay, now we can just substitute the value that we already have. Okay, but we don't have the molar mass. Okay, let's calculate the molar mass first. Okay, So P is 1. Now we can make the density as the subject. Alright, so we have here P, okay, times with molar mass, okay, over RT is equal to density. Okay, to make it easier, alright, so let's move it like this. Density is equal to pressure times molar mass, okay, divide with RT. So just substitute the value. P is 1 atm. Okay, molar mass of methane. Okay, so methane, we have carbon 12, okay, 12 gram per mole, plus 4 hydrogen, we have 4 hydrogens, so 4, okay, gram per mole, okay, and then divide with R is the constant, 0.08206 LATM over K mole, okay, times with temperature, must be in Kelvin, remember, 273.15 K. Okay, so you can just cross the unit. Okay, so we have here mole, okay, and then K with K. So we have the final answer. When you press your calculator, you will get 0.7138 gram per liter. Okay, gram per liter. So let's look at the distribution of the marks. So 3 marks, okay, for this question. So the first one, you will get 1 mark, okay, for the formula. Alright, for the formula itself, when you derive until you get the density. And then for the substitution, 1 mark, and the final answer you will get 1 mark. So altogether 3 marks.
Okay, we are moving to question number 2, subjective. 2A, sketch the phase diagram for carbon dioxide. Given you here is table 1, okay, contains triple point and critical points of carbon dioxide. And the last sentence of the question stated that label the sublimation point of carbon dioxide. So you have to highlight the sublimation point that you have to label at the end of the step, okay. So the first step, what you have to do is you have to draw x-axis and y-axis. The x-axis here is temperature in degrees Celsius or Kelvin, depending on the questions given. And y-axis here is pressure in ATM. That one is mark number 1. The second mark is for the correct shape of graph. So you have to know how to draw the phase diagram of carbon dioxide. That one is mark number 2. The next mark is for the correct region for phases. Okay, so you have to label which part is for solid, which region is for liquid and for gas. That one is mark number 3. Next, you have to label which one is triple point and which one is the critical point along with their pressure and temperature together. Okay, that one is mark number 4. And the last mark is when you answer the last questions. Okay, the last question is asks you to label the sublimation point. Sublimation occurs when solid turns to gas, and it occurs at 1 atm. So from 1 atm, you will draw a line, okay, to the graph, and you will put the point for, okay, sublimation point there. So you will get another mark for that. So for the answer given here, the student didn't put the sublimation point, so he only get 4 marks for these questions. Okay, question number 2B, you have to complete the table 2 below with the appropriate answers. Okay, there are type of crystal, type of intermolecular forces, and example. Okay, number 1 is for ionic solid. Type of intermolecular forces is electrostatic attractions, and example is sodium chloride. Number 2, molecular covalent solid. Okay, type of intermolecular forces is covalent bonds, and example is solid carbon dioxide. Okay, and number 3 is a metallic solid. Type of intermolecular forces is metallic bonds. Example is ferrum.
Now, for question 3, let's change the unknown into A, B, C, and D, which we gave you boiling points in Kelvin. What is the definition of boiling point? Boiling point is the temperature at which the vapor pressure of a liquid is equals to the atmospheric pressure. We want you to give this exact definition. Now, we have to arrange liquids A, B, C, and D in order of increasing vapor pressure. So we have to look at each one of the values where we can see that the lowest boiling point would be the one for B. Since B has the lowest boiling point, it would be more easier for it to become gas. Therefore, the more gas B produces, the higher the vapor pressure is. So the next boiling point would be belongs to D, and then followed by A, and then followed by C. C has the highest boiling point. It is difficult for it to become gas. Therefore, the vapor pressure is low. Lowest out of all. Now, question C asks you to state which of the above substances or liquid has the diffusion rate highest at 30 degrees Celsius. So basically, we look at their boiling point at 30 degrees Celsius. B is already a gas because B has the lowest boiling point. Therefore, B would be having the highest diffusion rate because gas particle has highest kinetic energy. Here, you explain in terms of kinetic energy the 4 postulates that we have learned previously. Okay?
Okay, question number 4. A yellow light near the middle of the visible light region. Okay, visible light region. Okay, underline this visible light region. As we know, as we learned in chapter 3, when we say visible light region, it is in Balmer. So when we say Balmer, do remember the ground state for Balmer will always be ground state is N1 is equal to 2. Okay, of a spectrum has a frequency of 4.57 exponent 14 per second. State the series where the yellow light is likely to be found. Okay, so the answer is Balmer. Okay, so 1 marks here. Okay, so B, calculate the energy of the yellow light in kilojoule. Okay, so right now we have frequency given in the equation. This one, right? So we have frequency. So we need to find delta E. So we can use this formula with the Planck constant. So Planck constant is constant given in the yellow page 6.6256 exponent, okay, negative 34, okay, 6 negative 34, okay, times with the frequency 4.57 exponent 14. So you will get this answer in joule first, which is okay 3.0279 exponent negative 19 joule. So since the question asks in kilojoule, so divide with 1000. Okay, so that you will get 3.0279 exponent negative 22 kilojoule. So here, okay, 2 marks. Final answer with the unit kilojoule, 1 marks. And then this formula or substitution, okay, 1 marks. Okay, formula or substitution, 1 marks. Okay, question 4C, determine the transition. So transition is the movement of electron, the excitation of electron from higher energy level to its ground state. Okay, do remember, from higher to lower ground state. Okay, so right now, okay, for the yellow light, okay, so we already calculate the delta E, right? Delta E, we use this formula, delta E is equal to RH, Ribert constant, okay, 1 over N1 square minus 1 over N2 square, where N1 will always be smaller than N2, or in another words, N1 here will always be the ground state. Okay, so ground state. Okay, so remember this delta E must be in joule. Okay, so we substitute. Okay, 3 3.0279 exponent negative 19 joule. Okay, is equal to Ribert constant 2.18 exponent negative 18. Do not take the 1.097 because that one we're going to use with the 1 over lambda formula. Okay, so 1 over, as we said, Balmer ground state is 2 square minus 1 over N2 square. This one we want to find N2. So which is the higher state, higher energy level. So you calculate and then we get N equal to 3. So you need to rewrite transition of yellow light, okay, transition electron, okay, from N2 which is 3 to N1 which is 2. Okay, so 2 marks here. So this is considered as 1 marks, and then N2 is 1 marks, and then this one formula or substitution 1 marks. So there are an extra marks here. Okay, so total for question number 4, okay, 5 over 5. Okay, so sorry, even though you get 6 over 5, but max we will take 5 over 5. Okay.
Okay, let's go to question number 5. Okay, a set of quantum numbers of 3 electrons. Okay, we have 3 electrons here that are filled in the orbital of highest energy level of atom E is given below. Okay, so we have 1, 2, 3 sets of quantum numbers. Okay, and if we refer to the spin quantum numbers, they are all negative half. Okay, they have the same spin. Okay, and the question A, determine the type of orbital designated by the above set of quantum numbers. How to know what is the answer? How to get 4p3 here? Okay, the answer is correct. Okay, but how to get the answer? Okay, we know that when we have quantum number 4 here, this is actually N, L, M, S. Okay, so right here we have N equals to 4. Okay, so N is equals to 4. Okay, and then L is equals to 1. L is equals to 1. When L equals to 1, we know that the shape is P. Okay, so the type of orbital is 4p. Okay, it is 4p. Okay, and the question said 3 electrons and we have 3 sets of quantum number, so 4p3. So that's why the answer is 4p3. Okay, sketch the shape of the above orbitals. Okay, how to know how many shapes that you have to draw? Okay, when you have 4p3, okay, if we draw the orbital diagram of 4p, okay, this is orbital diagram, and we have 3 electrons. Okay, let's substitute the electrons. 1, 2, 3. Okay, according to Hans rule, okay, this is degenerate orbitals. Degenerate orbital. The electrons, okay, must be arranged, singly arranged, okay, with the same spin before they are paired. Okay, so that's why we have 1 electron in each box, okay, of 4p. Okay, so there are 3 boxes with electrons, meaning you have to draw 3 shapes of p. Okay, so it is 4px, 4py, and 4pz. And make sure when you draw the shape of orbitals, label the axis, okay, label the axis, and also label the name of the orbitals. Okay, and one more thing, okay, although this is only 1 electron, there is only 1 electron in one box here. This is also 1 electron, 1 electron. It doesn't mean that you have to draw one or half of the shape. Okay, because you are not drawing the electron, you are drawing the shape of the orbital. Okay, what is orbital? Orbital region, okay, where we have high probability of finding electron. Okay, where we can find electron, it is in the orbital. So it is the region, okay, kawasan, okay, where we can find electron. So maybe electron is here, maybe it is here. Okay, we don't know. Okay, so we are not we do not drawing the electron, we draw the shape of the orbitals, the region where we can find the electron. Alright, next, okay, we want to have the complete electronic configuration. Okay, we want to write the complete electronic configuration of atom E. Okay, we know that from the previous question, and we know that there are 3 electrons in the highest orbital, energy orbital, which is 4p3. So how to get the electronic configuration of atom E is to complete all the electrons before you can reach the 4p3. Okay, it means before 4p3 we have 3d10, okay, 4s2, 3p6, 3s2, 2p6, okay, 2s2, 1s2. So this is the correct answer for the complete electronic configuration of atom A. Okay, and then next, okay, C, if 5 electrons are removed from atom A, what is the formula of the ion form? It is A5 plus. This is 5, should be 5. Okay, A5 plus. Okay, correct. Okay, and write the SPDF notation and draw the orbital diagram of the valence electron of the ion form. Okay, it asks for the ion. Okay, so SPDF notation of the ions. This one is wrong. Okay, this one is wrong. Why it is wrong? Okay, let's see the complete electronic configuration of atom A. Okay, you have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. Okay, we can also write this as 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. Okay, after that 4s2, 4p3. This is another way to write the electronic configuration when the 3D is fully filled. Okay, we have 4p. Okay, I'm sure most of you have learned chapter 4, okay, on how to determine the group, the period, the block of the elements. This is actually element from period 4. Okay, it is actually from period 4, and then it is from group, what group? 2 plus 3, group 15. Okay, group 15. Why group 15? Because it is from block P. Okay, so it is from block P, so the group number of block P we plus with 10. Okay, the valence electron plus with 10. Okay, so based on this, actually you can also write the electronic configuration similar with what you have learned in school. Okay, it's to check whether your answer is correct or wrong. Okay, so right here it is 2 dot, this one is 8, okay, dot, this one is actually, okay, plus with the 3D 18 dot, okay, 4s and 3D, sorry, 4s2 and 4p3 is 5. Okay, so it is 4, 1, 2, 3, 4, period 4. Okay, group 15 because the number of valence electron is 5. Okay, plus with 10, so group 15, it is from P block because the configuration is in the range of NS2 and P1 until NS2 and P6. Okay, so from there we know that the valence shell is 4. Valence electrons is 5. Okay, so we want to remove 5 electrons. From where? Must be from the valence shell. Okay, so valence shell is 4. So when you want to remove the electrons, we start with the outermost shell. So outermost orbital, which is 4p. So this is 3 electrons. We need another 2. We go to 4s. Okay, so meaning this is the electronic configuration of the ion form. Yeah, this is for the ion. Okay, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. So it should be 3d10 here without the 4s2. Okay, and then this one is also wrong. Okay, so how to write the orbital diagram or draw the orbital diagram for the valence electron for the ion form? Okay, so next this one. This one is for atom A. How about ion A? Ion A, valence shell. Okay, how to determine whether using the electronic configuration SPDF notation? Check the largest value of n. So the largest value of n is 3. Only 3. And not 3s2, 3p6, 3d10. That one is the configuration. Okay, the shell is 3. Okay, and valence electron is 10 plus 6 plus 2. Okay, valence electron of the ion is 2 plus 6 plus 10. So you get 18 electrons. Okay, so the electronic, the SPDF notation and of the valence shell. Okay, this is not the answer yet. It should be 3s2, 3p6, 3d10. Okay, so for the orbital diagram, okay, of course you have to draw 3s and then you have to draw 3p with 3 boxes and then draw 3d with 5 boxes and complete all the electrons. Okay, so 2 in 3s and then in 3p, 6 electrons, and in 3d we have 10 electrons. So this is the answer for the orbital diagram of the valence electron and the SPDF notation. Okay, it should be this one and this one. Okay, and also this one. So 3 marks here. 1, 1, 2, and 3. Okay, last question. Okay, we have Chromium 24, CR24. And this is actually one of the element which does not obey the Aufbau principle. Okay, in the last page of chapter 3 notes, okay, you can see the discussion about chromium and copper. Okay, write the electronic configuration of for chromium atom and chromium ion. And your friend here just gave the electronic configuration of chromium atom. Okay, so it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. Okay, you have to write the actual configuration of chromium. Okay, if you are asked about chromium or copper, read the question carefully. Sometimes it asks for the electronic configuration that obey the Aufbau principle. Okay, but this question does not ask about that. Okay, it asks for the electronic configuration of chromium, so give the actual configuration. And the chromium ion, okay, it does not ask about Aufbau, as I said just now. So it asks about the ion. What is the ion of chromium? The ion of chromium has positive 3 charge. Okay, it means we have to remove 3 electrons from where? Okay, look back at the configuration. Okay, let's do what we have done for the previous question just now. Determine the valence shell. Okay, so based on the electronic configuration, the largest value of n in the configuration is 4. Okay, so it means valence shell is 4. What is the valence electron? The valence electron is 1 plus 5. This is transition elements. Okay, transition element. So it is from block D. D block element. Okay, block D. D block element. So D block elements. Okay, the number of valence electron. Okay, is the group number. Okay, number of valence electron is also determine the group number. So we have 1 plus 5, so it is from group 6. Okay, so we have 6 electrons, 6 valence electrons in chromium. So where to remove the electrons? Okay, remember when you want to remove the electron, it must be starting from the valence shell or the outermost shell. Okay, so the outermost shell is 4s1. So we remove 1 electron from here. Okay, so that it is not enough yet because we need 3 electrons. Okay, so the other 2 electrons you have to take from 3D. Okay, so left here 3D, 3. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 3D, 3. Okay, so that's the configuration of the ion, okay, of chromium. If you want to write it as Cr3+. Okay, so actually chromium also have oxidation number Cr+, if I'm not mistaken. Okay, so you have to remove 1 electron from 4s, so it left as 3p6, 3d5. Also acceptable as the answer. Okay, so this is the answer for chromium. Okay, chromium ion. Next, explain why the electronic configuration of chromium atom violating Aufbau principle. Okay, the correct answer is the because the fully filled orbital, fully filled 3D orbital. Actually, this is not fully filled. It is not fully filled, so this is wrong. It is half filled. Okay, half filled orbital because we have 3d5, not 3d10. Okay, so it should be because half filled 3D orbital is more stable than partially filled orbital. Okay, so that's the answer for number 5D.